Hi, this is Swati, and we'll today see the chapter Polynomials of grade ninth. So, this is a very important chapter. We will also have the same chapter in grade 10th. For grade ninth, you only have some basics and important concepts. So, let's get started. So, what is a polynomial? Polynomial is an algebraic expression in which the exponent of the variable is always a whole number. Very important. It's an algebraic expression. See here, meals means terms and poly means many. So basically it's many terms. So obviously the expression, algebraic expression consists of terms. So any algebraic expression is a polynomial only if the exponent, that means the power, is a whole number. For example, this is a polynomial because here I can see that this is a power, this is a power, and this is a power. All the powers are a whole number, so it's a polynomial. So let's understand few terms here. The first one is coefficient. What is a coefficient? Coefficient is the number with the variable. Now let's take this one. The coefficient of x cube here is 8. The coefficient of x square here is -3. The coefficient of x here is 1 by 3. So when there's no number, it is 1. And 2 is a constant. So now next is variables. Variables are basically alphabets. Operations. Operations are plus, minus, multiplication. All those are operations. And exponents are basically the power. Constant is a 2. So mixture of everything, coefficient, operator, variable, constant, mixture of everything forms an algebraic expression. Now we have types of polynomials. Types of polynomials have been segregated into two parts. You can divide based on the terms or based on the degree. So firstly, let us see how do we divide based on the terms. Now let's say if I have one term, it is known as monomial. See, meals means the terms. Mono means one. So one term, if an expression has one term, it is known as monomial. Let us take an example, 2x. It's a monomial. Now next is binomial. Bi means two. Two terms is known as binomial. For example, I can take 2x square plus 3x. Now this is one term, this is one term. Plus and minus separates the two terms. Now, trinomial. Tri means three. Three terms are known as trinomial. For example, 2x cube plus 4x square plus 3. This is a trinomial because it consists of three terms. You can also divide the polynomial based on the degree. Degree is basically the power. If my power is 1, then it is a linear polynomial. Let's say I have 2x plus 3. Here my power is 1. So degree is the highest power. To be more specific, it is the highest power. Now quadratic means degree 2. So we have seen quadratic expressions, right? All those are quadratic polynomials with the degree 2. So x square plus 2x plus 3. Now here my powers, I have 2 and 1. But what is the highest power? The highest power is 2. So the degree is 2. So basically degree is nothing but the highest power in an expression. Now cubic. Cube is basically 3. So cubic. If the degree is 3, the polynomial is known as the cubic polynomial. For example, x cube plus 2x square plus 4x plus 3. Here I have 3 to 1 as my powers, but the highest power is 3 and hence the degree is 3 and hence it is known as cubic polynomial. So this was about what a polynomial is and what are the types of it. Now next up is degree of a polynomial. You know that the highest power of a variable is known as the degree of a polynomial. We have already discussed. Now, if the degree is 0, if the degree is 0, now for example, I have polynomial of x equal to 5. So 5 is what? It's a constant. No variables, which means it is constant. So this is constant polynomial. So all the constant polynomials, if they ask you the degree for a constant polynomial, it is always equal to 0. Very important, they generally come in MCQs. Now next, if at all I have P of x is equal to 0. So this is known as zero polynomial. We will discuss it now. And zero polynomial degree is always undefined. For any zero polynomial, the degree is not defined. So now let's say I have a polynomial that is 0. Here my polynomial is 5. It's a constant number. So constant polynomial degree is always 0. But if my polynomial is 0, so it becomes 0 polynomial. For that, you cannot define the degree. These two are very important. You might get MCQ questions from it. Now, next is very important zeros of the polynomial. This is one important concept of this chapter. Now, what is it? The name itself tells zeros. If the value of the polynomial P of x is polynomial in x, becomes equal to 0 when we substitute x equal to a. Let's say I'm substituting any value due to which the whole value becomes 0. So that value that I've substituted is known as the zero of a polynomial. Let's take an example. Let's take a polynomial P of x, x plus 2. Okay. Now I need to find out at what value of x will this become 0. So if I take x as negative 2, let's say if I take x as negative 2. So P of minus 2 is what? Minus 2 plus 2, which is 0. I got 0. So when did I get the value to be 0? If x is equal to minus 2. So therefore, this minus 2 is known as the 0 of the polynomial. Minus 2 is known as the 0 of the polynomial. So at what value you are getting it as 0? That value is known as the 0 of the polynomial. Let's take another example. Let us take P of A is equal to 0. That means at A, the value of A is known as the 0 of polynomial. So when I'm substituting the value A, then I'm getting the expression to be 0. So then A is the answer. A is the 0 of the polynomial. Let us take a polynomial P of x is equal to x square minus 4x plus 4. So let us find P of 1. What is P of 1? P of 1 is basically substituting 1 in this. I get 1 square minus 4 plus 4. I get my value as 1. So 1 is not the 0 of a polynomial. Let me take 2. P of 2 is what? Substituting this in 2. 2 square minus 4 into 2 plus 4. 2 square is 4 minus 4 into 2, 8 plus 4. 4 plus 4 is 8 minus 8 is 0. So I got the value of this as 0. So when did I get the value to be 0? When I substituted x as 2. Therefore, 2 is known as the 0 of polynomial. 2 is known as the 0 of polynomial. I hope this concept is clear. So at what value you're getting the expression to be 0, that value is known as the 0 of polynomial. Now, we also have some important algebraic identities in this chapter. The basic ones are already there, which we have been learning from grade 8. Those are x plus y whole square, x minus y whole square, and x square minus y square. So here you have all the terms to be positive. Here also the terms are same, only the xy, 2xy term is negative. And this is x plus y into x minus y. Apart from these basic identities, we have some new identities introduced in this chapter. X plus y plus z whole square is squares plus product of each. Very easy to remember. Now, x plus y whole cube, x minus y whole cube, your terms are same. All the terms are same. X cube plus y cube plus 3xy into x plus y. Here also you have the term same, only you have negative in between. Now, this is one very important identity. x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square, and then minus xy minus yz minus zx. It's very easy to remember. Now last two is again individual cubes. The terms are same, only the signs are different. So it's very easy to remember. I hope you have understood. In my next video, I will cover the most important factor and the remainder theorem. Once we are done with that, we will only jump through the questions, important questions. Thank you.